Okay, so let's go to the topic generator expressions. Okay, so generator, we already seen the generator functions in the last class. So generator expression is something like it's a short notation for the generator functions. Okay, so now let us see from the generator functions again actually. For example, I want to define a generator function for, let us say, def gen, or I can just say normal function first, build squares. The same example, whatever I just took yesterday, same example, n. Okay, for um, I in range of n, result is equal to I to the power of 2 or result to the append. Return result. So result is a variable. I'm just defining inside it. Result is an empty list first. So this is a normal function because I am using the return statement to return the value. So now build square is my function. I'm just calling with, for example, 8. It is just going to return me a result of values. I'm just going to say, and I'm just printing values here. It is going to print the value squares of the elements or integers starting from successive integers starting from 0 to 7. That's what this program. So I have converted the same thing to, so see here, I can also do the same loop, the same thing, the same function in with the help of list comprehension. How I can do? So for example, for I in range of n, or for example, range of n, 8, let us say, okay, and I to the power of 2 is my element. So finally, I'm just forming a list comprehension. This is going to return me the same to same value, exactly the same value. So this entire function is converted into a single expression called list comprehension. This is my list comprehension code. Similarly, the generator function. So I'm just converting the same function into a generator function rather than normal function. So how I can able to convert? I can able to convert using the yield statement via yield I to the power of 2. Okay. And just changing the name of the function as gen squares. Okay. And return is not required. This is what my generator function for to achieve the same result. Okay, and this is my function definition. When I just call the gen square function, so what it is going to return? It is going to return a generator object always. For example, 8 is only I'm passing here. It is always going to return the generator object. We already discussed generator functions. When we are calling the generator functions, they are going to return always the generator object. So now I'm just printing the G is a generator object. This is the generator object which is generated while calling the gen square generator function, and this is the memory where the generator object is saved inside the memory. So how to get the values? We can able to call either next function, next of g, and also one more next. It's keep whenever you're calling the next function means on the generator, it's keep on getting the element by element 0, 1, 4, 9, 16, and so on. So just when I say I can also call g dot double underscore next double underscore, that is also being called. So I can just get the next element. So as soon as I just calling the next, it is going to get the next element in the result. So I can able to just convert this entire generator function to a single expression called generator expression, similar to the list comprehension. This is my list comprehension code. See here, I am also writing the same to same code for I in range of 8. Okay, I to the power of 2. So here, rather than list comprehension, if I list comprehension, I always mention the square bracket, open square bracket and close square bracket. But in case of generator expression, I just mentioned the parenthesis. So this is a comprehension code, but this is a parenthesis means it's a generator expression. So the same to same logic, whatever is the logic I have written inside the list comprehension, this is the code. The same code I have written, there is no change at all, as it is the same code. But I am not forming here a list because it's not a list comprehension. Parenthesis means a generator expression. So generator expression also going to return me a generator object, not the result. So when you just print G2, G2 is a generator expression. So it's generator expression object. Sorry, generator object, which is generated by calling the generator expression. This is my generator expression. And the generator object is saved inside a memory like this. This is the memory location where the generator object is present. So how I can get the elements on this generator object? It's the same to same concept. Next of G2. It is going to get the first value. So next of G2 again, going to the next value. So G2 dot double underscore next double underscore 4. The same code next element again. So it's keep on getting the next element as soon as I'm just calling the double underscore next double underscore or directly the next function. So this is called generator expression. Whatever is the code that we are trying to write inside the comprehensions, the same code we are also writing, and what is the rules that we have applied for comprehensions, the same rules also can be applied here also. No change. For example, I'm just going to change the generator expression like this. So G3, and if I percentile 2 equal to 0. What it means? So it means for every range of I, first it is going to check the I value is equal to even or not. If it is equal to even, then only it is going to generate the square of that element. And all such square of the elements will be present in a generator object because it's a generator expression. So if I say G3, obviously G3 is a generator object which is generated because of the generator expression like this. And this is the memory where the G3 object present in the memory. Now when I say G3 dot double underscore next double underscore 0. Okay, 0 is a even number. And now it's a 4 because 1 is not even number, it is eliminated. So 2 is a 1. So next again calling, it's a 4. 4 to the power of 2, 16. So whatever is the conditions or everything, whatever we discussed to write the code inside the any comprehension called list comprehension, set comprehension, dictionary comprehension, the same to same logics are also applicable here also while writing the generator expression, because the code inside the generator expression and the code inside the comprehension both are following the same rules of syntax. Only the parenthesis is denoting its generator expression. Square brackets denotes the basically it's a list comprehension. Curly brackets denotes it's a basically either set comprehension or dictionary comprehension. Any questions here? Generator expression.